Hello, my name is Christian Pavlak, and this is the second video for Mat650. So let's read it. A statistics teacher has 40 students in his class, 23 females and 17 males. At the beginning of class on a Monday, the teacher plans to spend some time reviewing an assignment due that day. Unknown to the teacher, only 19 of the females and 11 of the males had completed the assignment. The teacher plans to randomly select students to do problems from the assignment on the whiteboard. What is the probability that a randomly selected student has completed the assignment? Okay, since we have so much information at the very top, it'd probably be best to organize that information into maybe a table diagram. So I know our categories are that we have males and females, and then we have students that did complete the assignment. So I'm going to put C for complete. C equals complete. And NC for did not complete. So what we do know is we do have some totals. So I'm going to make a separate column and row to help us with these totals. We know there's a total of 40 students. We know in this class we have 23 females, so we're going to put 23 females here and 17 males. And unknown to the teacher, only 19 of the females and 11 of the males had completed the assignment. So as far as who completed the assignment, 19 females completed it and 11 males. So from here we can actually fill in the rest of the table. We know that if we add these together, we have 30 students that have completed the assignment. That leaves us with 10 students that did not complete the assignment, since they have total up to the 40. So then also going vertically, if we have 11 students that 11 males that completed the assignment and 17 that are total, that means there are 6 that did not complete it. And there have to be 4 females that did not complete the assignment. So from here we can actually answer this question. What is the probability that a randomly selected student has completed the assignment? So since we're looking for students that have completed the assignment, well, since we are not going on the basis of males or females, we're looking at total, the probability that a student has completed the assignment would be 30 out of the total number of students, 40, which equals 0.75. And that's it. So let's go on to part B. Part B says, what is the probability that a randomly selected student has either not completed the assignment or is a girl? Okay, so what we're looking at is this, the probability that the student has not completed the assignment, or, so we're looking at union, is a girl. Now, since these are two separate categories, what I can do is I can actually use the formula that the probability of A union B equals the probability of A minus the probability of B, plus the probability of B minus the probability of A intersection B. So in this case, we're just going to replace the students that did not complete the assignment with the probability of A, and the girls with the probability of B. So therefore, the probabilities, if we fill them in, would be, well, of all the students that did not complete the assignment, so we're going back up to the table, that would be these students, 10 out of 40, plus, and then the probability of girls, so if we're going back, the girls were these ladies, 23 out of 40. But then we have to subtract the intersection, because what happened was we considered the students that did not complete the assignment, some of those students were females. And then when we considered all the females, some of those were the ones that did not complete the assignment. So actually we counted those students twice. So in order to avoid that, what we have to do is we actually have to subtract the ones we counted twice, which is 4. So, finally, minus 4 over 40. With a little bit of arithmetic, 10 plus 23 is 33, minus 4 is 29 out of 40. There you go. Okay, next, what is the probability that given a female student selected randomly has completed the assignment? Now, the fact that I see the word given is always a giveaway for conditional probability. Conditional probability. So what I'm going to do is I'm going to first kind of identify what's what and then use the conditional probability formula to help me. So what is the probability that given a female student? So I'm going to call that event A. So A will be the female student. Selected randomly has completed the assignment, so this will be event B, the completed assignment. So what I'm looking for is the probability of B given A. Or, if we wanted to go back to our original notation, the probability of a completed assignment given the fact the student was a girl. So what we want to do is we want to take the probability that the completed assignments that were completed by girls, so the intersection of those, and then divide it by the probability of girls. The reason this formula works out is all we're doing is we're assuming we're looking at just the girls. And then we're only taking the students that actually completed the assignment of those girls and dividing by the total number of girls. So to kind of go back to the table and give that a visual representation, all we're doing is we're isolating the females population. So we're only looking at this. Nobody else in this table happens to exist. So we know we're choosing a female. There's 23 of those females. And what we're wondering is what is the probability that of those 23, it's one of those that completed it? Well, we can see it's 19. So if we went back, now since I did mark probability, that we would do 19 divided by 40 over, and then the total number of females was 23. Now the 40 is irrelevant in this case because we're not looking at the total group. So regardless, this still reduces to 19 over 23. That's it. And last, are the events selecting a female and selecting a student who has completed assignments independent? Justify your answer. So this is a great question because you're identifying if there's a bias almost. If just because you're a female, you are more likely or less likely or equally likely of selecting a student who has completed the assignment. Well, the best way to analyze this would be to compare the probability that just because you're female, did you complete your assignment, and of all the students that completed their assignment, if those two are the same, then we know the two events are independent. But if they're not, that means there's a bias one towards the other. So we can actually use our answers from part A and part C. Part A, if we go back, was what is the probability that a student selected at random has completed the assignment? That was 30 out of 40. So the probability a student has completed the assignment was 30 out of 40, which we said is approximately actually it's equal to 0.75, but we're going to use approximation symbols. Then what we're going to do is we're going to look at, okay, if you knew you picked a female student from part C, what is the probability that of those females, one of them has completed the assignment? That was 19 out of 23. Now, if 19 out of 23 is equal to 0.75, then the two events are independent. If they are not, then they are not. So what I'm going to do is I'm going to get the calculator. Here we go. And simply do 19 divided by 23. Now Now this means this answer is approximately, I already forgot, 8261. So 0.8261. You can clearly see these two are not equal. So therefore, since this answer is actually greater, and that was the conditional probability, the one that we knew since we're picking a girl, this lets us know that knowing the student is female increases the probability that the student has completed the assignment. Now, if that didn't exactly register the conditional probability, maybe that was difficult, what we can do is we can look at this at a different angle. We will still use our answer from part C. Now, the probability that a student, a female chosen at random, has completed her homework is still 19 out of 23. That was the probability a student has completed their assignment given that they're female. What we can do is we can compare this to the probability that a student has completed their assignment given that they're a male, a boy. So if we want to do that, and we go back up to our table, what we're going to do is get rid of all this and then just focus on the males. Of those that completed the assignment, 11 out of the 17 have done so. So this one would be 11 out of 17. We still know this is 0.8261. And now 11 out of 17, that looks a little closer to half. But to get an exact answer, 11 divided by 17, 6471. So 0.6471. So you can clearly see just because you're a girl means you have a better chance of completing the assignment versus boys, it's less likely. And since those are the only two options, we know that these two events are not independent. Just because you're a female does not, selecting a female and selecting a student at random who has completed the assignment, those two are not independent. Thank you.